Hello everyone, I am Sakshi Kumari and today I will be presenting and explaining the topic application of Bernoulli's principle in aircraft flight. So to start this, I would first like to put forward a question that we all know that an aircraft which weighs several tons is able to fly smoothly in the air. But have you actually ever wondered what keeps them airborne? So, the answer to this question lies in some very important concepts of physics. One of the major principles involved in aircraft flight is Bernoulli's principle. So, today we will understand what Bernoulli's principle actually means, and then we'll go on and see how this principle is applied in aircraft wings to generate the desired lift and keep the aircraft airborne. So let us start with the basic introduction to Bernoulli's principle. Bernoulli's principle was introduced by the scientist Daniel Bernoulli in the 18th century. Now, this principle mainly deals with fluids in motion. Now, the word fluid, it includes both liquids and gases. So apparently air can also be treated as a fluid. Now, Bernoulli discovered that when a fluid starts moving faster, its pressure decreases, and likewise, when the fluid moves slower, its pressure increases. At first, this may sound very strange, but this relationship between pressure and velocity is very important in many practical applications that we will be seeing ahead. So here in this slide, we have the mathematical form of Bernoulli's principle. The equation basically represents conservation of energy in a moving fluid. Now the first term, it represents the pressure energy. The second term represents the kinetic energy. And the third term represents the potential energy because of the height. And according to this equation, the total energy of the fluid, it remains constant along a streamline. So again, if the velocity of the fluid increases, some other form of energy must decrease to maintain balance. In most cases, the decrease happens in pressure. That is basically why high speed fluid is associated with low pressure. So yeah, moving forward, we will look after some real life examples of Bernoulli's principles. So it is not only limited to the aircraft, which we'll be mainly talking about today, but we actually observe it in many day-to-day situations. For example, in a perfume spray, in a garden hose nozzle, or in chimneys or ventilators present in your house or in industries. So this is all the places where Bernoulli's principle is actually helping the perform the desired action. So now, before understanding the role of Bernoulli's principle in aircraft wings, we first need to understand how an aircraft actually remains in flight. That is more important. So, the four forces that are important and are acting on the aircraft are: first is the lift. It is the force which is acting upwards and is also helping the aircraft rise into the air. And the second force is weight, which acts downwards due to the Earth's gravity. Third being the thrust. It is produced by the aircraft engines, which pushes the aircraft forward. And finally, the drag, which is the air resistance that opposes the forward motion. So, for an aircraft to fly steadily, these forces must remain balanced. Like lift should balance weight and thrust should overcome drag for it to move forward. Once the aircraft gains sufficient speed, the wings start generating enough lift to keep the aircraft airborne. Now let's talk about the design of the aircraft wing. Aircraft wings are not flat if you have ever noticed. They are specially designed in a shape called airfoil. If we observe carefully, the upper surface of the wing is more curved while the lower surface is comparatively flatter. Why is this? This is because when the aircraft moves forward, the air it splits from the edge of the wing. The air traveling over the curved upper surface, has to move faster as compared to the air below the wing. And this difference in airflow speed becomes the key reason for lift generation. Now, this is where Bernoulli's principle directly comes into action. Now, since the air above the wing moves faster, the pressure above the wing decreases. At the same time, the air below the wing moves comparatively slower, so the pressure below remains higher. As a result, a pressure difference is created between the upper and lower surface. Now, as we all know, that the nature it always tries to balance the pressure difference. Because of the higher pressure below and lower pressure above, an upward force is produced, which is basically called lift. And this lift is what allows the aircraft to rise and remain in air. I've also included a picture of the aircraft. So this is basically how the air flows from the upper curved surface. Again, this is like basically the steps in how the aircraft wings generate lift, which we have already covered in the previous slide. Okay, so then to conclude, the Bernoulli's principle it has helped explain the relationship between pressure and velocity um in a moving fluid, and we have observed that faster moving air creates lower pressure while slower moving air creates higher pressure. The aircraft wings it uses the very same principle very effectively to generate lift through pressure difference. Thus, this concept from fluid dynamics has become one of the most fundamental reasons why modern aircrafts are able to fly. So, today, this presentation shows how physics is not just theoretical but also deeply connected to real world and aviational technology. So, yeah, thank you.